to title this class, Are We Destined to Act on the Future? And there's an intrinsic paradox here, which a lot of people, everyone has to battle with, which is this question of if there is a future state that is acting on the present, which is knowable, and it's knowable because we can change our behavior in accordance with it in order to avoid a tragedy, a drought that we can foresee coming on because we've planned ahead, because we've identified certain seasonal changes. If there is this future, then does that not also mean that we don't have freedom? Right? That our ability to freely choose what we want to do is conditioned by that future state which already exists. Now, a lot of people want to believe, right? They want to believe that the universe is good, that the universe is guided towards becoming better, and it's something which touches everybody's instincts, their soul, that yes, okay, things are not just going to shit. The universe isn't winding down to some heat death. Things are directed towards increasing complexity and improving. And oftentimes, you'll talk to somebody who will watch a webcast, a website, or have a good discussion, or come to a class, and then they're going to be quite inspired, and then all of a sudden they go back into their world, right, their job, start watching this pessimistic shit on the news, and all of a sudden you realize that there's a battle, because what they hope is true about the universe, these ideas of the universe being creative, moving to higher states of organization, and the world that they see around them materially unfolding are two very different images. Right? There's wars happening, there's an economic breakdown, and this inability to reconcile this idea that we actually have a capacity to act on the future is at the heart of a lot of good people who seem to simply cave in to the peer pressure and say, well, we got to cut the budget. The markets say this. There's a mechanism in place that says we have to do this. We don't want to, but grandma's got to die, or whatever. It costs too much money. Or that's the type of thing you tend to get on the monetarist side of things, on the environmentalist side of things, like JP went through. You get this other logical derivation of a presumed reality which doesn't necessarily exist, but that sounds a lot like, oh, well, we are overpopulated, we do have to reduce our population, we have to know our constraints, know our boundaries, and there's not really an idea that perhaps those boundaries are not real, they're just a chimera, that you don't have to work around those boundary conditions, right, of the markets determining a certain thing or another, or that that global warming is somehow caused by people. Maybe these things are not actually true, and we shouldn't be talking about depopulating Africa in order to cut down, or at least reducing everyone else's quality of life to the consumption levels of Africa, because apparently, Africa consumes so less, so they're so much greener. Well, there's a catch to that. So you've got a table is that the best way to reconcile this is to develop our scientific imagination. But that's not so easy to do, because our whole idea of what science even is these days is really out of whack. And that's the fact that we're not governed by just mechanical rules, and that science is not just about coming up with interesting formulas to try to describe why things are happening, right? That's not the purpose of science. To try to make up a better description, an ever better description, using a reconfiguration of existing knowledge, or at least existing formulas to describe why do earthquakes happen according to the laws of Newtonian mechanics? Why is, what is at the center of the Earth? What is the model that describes the atom? These are all models that we talk about as if it's already known, but really, if we're honest to ourselves, we really have no clue that the center of the Earth is as it's commonly described, some ball of just molten lava with a bit of an iron core that moves up and down, that has a mantle, that has a crust. We could say that there's probably a certain generalization to that which is correct, but we've really only scratched the surface. And all of these models that we use to describe these things, or even that the universe is on its wear and tear moving towards a state of entropy, of heat death, of no change, these are what the common scientific community tend to believe and enforce in the school system. But really, when you actually ask the question of how do they derive these conclusions, it's really there's nothing to it. They're just rearranging what current formulas we've gained up until now. And so there's a lot of discoveries to be made. The best way to do this in developing our scientific imagination is to start looking at those phenomena on the Earth which are organizing the development of life, which are really organizing the development of all change in matter, space, and time. Not as mystical things, but rather as principles that are knowable to the mind of man. And we've been using this fight over the question of earthquake prediction, which is a proven science that you guys will find all over the website. We've given classes on this. This is where the Achilles heel of the empire is showing itself, because while the empire has been trying to convince people that we cannot actually know qualitative states of what organizes the universe, actual small pockets of real scientists have been demonstrating that earthquake forecasting is entirely possible, but not when you use the common formulas that are accepted. It's only when you start moving into the domain of cosmic radiation, which you're looking at here is the magnetosphere of the Earth. Right? Good. A more close-up expression of the magnetosphere that some of you may be familiar with, if anyone's been to the Yukon, which is the aurora borealis. And these phenomena that are acting efficiently, like the ionosphere, which is a domain about 40 to about 600 kilometers above the surface of the Earth of high ionized plasma. These interconnected phenomena are those places which our forecasters, these forecasters who have been making these long-range forecasts in earthquakes, have been using to successfully make their forecasts, which of course has not been used and is almost completely denied by the experts, especially in the West, that this even is possible. But they're using the ionosphere, they're using the magnetosphere, they're using the energetic domains of what's governing life. Yes?
Can you just point, where's the ionosphere?
The ionosphere here is this
Topmost.
this domain here, polar lights, from the 80, actually I was wrong, it's not 40, it's 80 kilometers, all the way up to about 800 or something.
I thought because on the left it doesn't say.
Right, yeah, sorry, it's kind of a miss. But what's interesting is that right now we've been fighting for a long time to get people to think in terms of cosmic radiation and these energetic processes as the key to making the important breakthroughs that human beings have not made since Einstein. But I mean, you could say that we have not made any real important breakthroughs in universal principles in a few generations. And the irony is that these are the places that you cannot see with your senses. That if you try to know the magnetosphere of the Earth or the ionosphere or the ozone layer, if you try to know these things with your senses, you'll never get anywhere. So if the current priesthood in science says your brain is just the sum of your sense impressions, then how did we come to know these things to begin with? Obviously not by those terms. And we've got phenomena that is acting on the Earth of a magnitude that we have to go beyond. We have to go beyond these simple, small, solar minima to solar maxima cycles where the sun becomes very active and very inactive every 22 years. That's something worth considering, because that's very important in terms of what's driving things like earthquakes, the fluxes of the ionosphere and other things. But we have much greater cycles also that we're capable of understanding. Us little things here on the Earth that have only had written records of civilization for a few thousand years, such as the 62 million year bobbing up and down of the solar system around the galactic plane of the galaxy. These are really considerations that we have to be not afraid of, but really optimistic about, with a certain faith that human beings can, by knowing these dangers, act on them to protect humans. Right? This is the difference between a lot of the 2012 cults, the things like that you get online, especially around the global warming issue, is that the future exists, there's dangers in the future, but there's nothing you can do about it, except for maybe get off the grid or, do these little things. This future, your free will has no ability to act in accordance with how the universe operates in order to affect that destiny in any way. And these 62 million year cycles are important, and we've gone over this in many of our videos because what we do know, and we'll get back to this towards the end of the presentation, is that the mass extinctions that occur periodically in the fossil records also happen along this very same periodicity. There's a recent discovery that was made. These conceptions are not unobtainable for anybody to start developing grasp of. And the idea is we should all aim to focus on developing our mind and our conceptions in such a way that the most complex ideas of the frontiers of science should be accessible and understandable to anybody in your society. Science is not a mystical thing just for geniuses sitting in a back room. But if we're going to have a society that is capable of democratically organizing itself in self-governance in such a way that we don't get Barack Obama's or some other idiot who will be a puppet of a financial empire that will push policies that will destroy our future, then everybody in that society has to have the quality of mind that can see with their reason and not just with their eyes, that don't derive judgments based upon what their immediate senses tell them, but actually think through what are the policies, what are the intentions, what are the higher principles of where my society is going, and make the judgment according to that principle, that idea, not simply, oh, this person's words make me feel good. I'm going to vote for that person or another, And I'll keep in mind that the idea of the future organizing the present is going to be an important theme to keep in mind throughout this entire thing. Now, oops. So the way I'm going to lay out this class is in 3, maybe 4 waves. But the first one, I'm going to create a little bit of context. I've created some context in terms of the sun, the environmental, the electromagnetic environmental conditions in which we as a political species exist and other life has evolved. But I'm going to look a little bit at the actual historical development of some of these key ideas, because when I mentioned that things have been tending to explode in the form of waves, these discoveries in time, it's important to just get an appreciation of them, because I'm going to lead this back to, of course, the question of biomagnetism, which is why we're all here, and how this investigation is a direct proof that the universe is good, and that it's pulling us towards a better place, but not without our participation. So the first thing up is that after the Renaissance is where we had really seen a huge explosion. For 2,000 years after the collapse of Rome, there was really nothing in terms of ideas being expressed to develop human society. It was really lame. So they call it a prolonged dark age. Not a lot of light. But there's something that occurred around the period of the Renaissance which gave us an explosion of medicine, the fields of science, of astronomy. All of these things opened up for us. And human potential expressed itself in new creative ways that we'd never seen, both in science but also in the domain of politics. Ideas like the nation state, this idea that the people are not just cattle for a feudal lord, but that actually have certain inalienable qualities and rights because of this equal capacity and power of reason. These are things that they were theoretical before that, but they weren't practiced before that period of the Renaissance in any great measure. Now, after Kepler's discovery, which we've been working on for a couple of years, and we're actually doing work on this a couple of weeks at the office, Kepler's original writings of how he discovered universal gravitation, you had, for the first time, the expression that physical science is not just for a small priesthood. That you can actually you could get out of the world of simply building descriptive models, which is what everyone was doing about how astronomy worked, how the planets moved around the sun, maybe how the sun moved around the planets, And all of these, between Copernicus, Ptolemy, Tycho Brahe, everyone who had developed these simply descriptive models to follow the basic positions of where you'd see the sun, or where you'd see the positions of the planets and the sun as the years progress, there was no intention to find a cause, but all of them worked almost perfectly. Kepler was the first guy to actually prove that, no, simply creating a mathematical geometrical model is not real. It doesn't have any increased power of the human condition within the universe. It doesn't give us better insight into how the universe works, or better insight into how the mind works in relation to that universe. So with Kepler's discovery, we realized that, okay, the universe is actually arranged in a harmonic organization. It's not just for some geometrical formula that the planets are elliptical. It's that the planets are elliptical because there's certain least action pathways that if any other path was chosen by that planet as it moves around the sun, it would be using more effort to do less work. And that the reason why the orbits are at the distance that they are isn't just random either. It's that there's a harmonic organization. And this is consistent with what Kepler proved in the Harmonies of the Worlds. And this, after a lifetime of fighting against insanity inside of religious conflict, Kepler's faith in the idea of a creative universe that could produce mankind as the smallest mirror image of that universe's power as a whole was brought to bear. And we now have our understanding of gravitation to thank to Kepler and a variety of other fields, from crystallography to a whole bunch of things that you could imagine. Nobody gives Kepler credit for, but they wouldn't exist if this guy had not done what he had done. Now, at that moment, you could still sort of say that the only type of energy that we could identify was perhaps fire. You could still say we were living in a material type of universe in a certain sense, but that for the first time Kepler cracked that box a little bit, right? We could see that things were seemingly fixed, but there was a certain species or emanation being generated by the sun that would keep things organized in a certain way. Now this is the domain of the unseen. This is real science. You're trying to see what's unseen but is acting efficiently on us, so that you could have the effect of better forecasting of where the planets will be deep into the future. And this is exactly what we got from Kepler. And also making new discoveries. So now, Benjamin Franklin comes in the scene. And I'm skipping a lot of people here. I'm just going to go through a few key moments in history. But what you had at one very important point around this period of a generation or two between Franklin, Luigi Galvani, and Ørsted, was that the separate domains of chemistry, electricity, magnetism, and life, which everyone thought were completely irreconcilable and different, we started discovering, there's some connectedness here. After Franklin discovered that electricity is not just some angry gods shooting lightning bolts at sinners on the earth, but actually something which is knowable to man, and thus harnessable in the form of bringing light into our houses, lightning rods that stop it from blowing up buildings and churches. But that these universal forces are actually something which can make our lives better. The idea of magnetism was then still understood as being something which you couldn't find a relationship between electricity and that. Similarly, life. And at a certain point here, Luigi Galvani was the first guy to discover that, indeed, life itself, by simply shooting a little electric current into a frog's leg after it had died, he saw it twitch. All of a sudden, we realized that life itself has an electric pulse. Right? Ørsted, similarly. Everyone had said it's impossible, there's no connection. Ørsted comes out, and he finally proves that, indeed, electricity and magnetism do coexist, and that magnetism is really just an effect of electricity, such that everywhere that there's an electric current, you have a magnetic field. You can't see it. No human has ever seen it. But we know they're acting efficiently on us everywhere. It's the reason why we're not getting burned to crisps by gamma rays right now, or the sun's coronal mass ejections that it's throwing at us at high speeds that are not very pleasant to life. But these are things that we now can say, because of their discoveries, we know, and can thus know better. I would say, just to show this is kind of a fun image, because this really challenged our entire idea of matter, especially at that same time when Franklin's ally Lavoisier, who was one of the leaders of the first attempt at establishing a real French nation-state, whose head was chopped off by a story that we've written a lot about. When Lavoisier made the discovery as well that what we thought were different elements are actually all connected, that water is not a basic element into itself, but can be broken down even deeper into oxygen and hydrogen through electricity, ironically, electrolysis. What we discovered is that increasingly in these elementary states of molecules, nothing comes into being from nothing. Which is what people tend to believe before that there's just new things that just come into being without any cause. Right? But what he discovered is that, no, actually, things are just transforming, all elements are just transforming in form. But there's no creation without a cause. So you have ice melting, becoming a liquid, which was a matter, becoming liquid, which can then continue to heat up to become a gas, right, which you can then bring back together to become liquid and freeze according to certain temperature variables to become ice again. And these things have a certain transformative quality, but also electromagnetic. Now, it took a while to actually figure out what fire was, because you think about solid, liquid, gas, and you realize that there are these basic elements. But fire was an anomaly for a very long time, because we could find every single one of the elements in every single state. But where does it occur in fire? And this is the first starting point of plasma, that there is actually an electric current. And now today we can actually say that everything that emits light is also carrying a certain voltage potential as well, which was discovered a little bit later on due to these discoveries. Now, another big wave happened when, in 1865, you had Dmitri Mendeleev, who brought together the periodic table. When everybody thought that these different elements could just be, it's kind of like alchemy. They're just everywhere. You could approximate what common qualities they have, but you couldn't find an organizing principle behind all of the elements. Mendeleev, even before we discovered most of them, or like 13 of them that weren't even known yet, had realized that there's certain periodic qualities to them that react in very interesting ways. Like the earth metals will all, if you put salt into water, will have a very combustible effect. And similarly, all the ones below salt, from cesium, barium, if you put them into water, you'll see more increased, intense chemical reactions occurring. You don't want to be around it when you get to the lower ones. These things will blow up on you. But regardless, this ability to see that the current understanding and no configuration of a current understanding would allow me to discover what organizes the material world. That knowledge that you had to make a creative breakthrough outside of the fixed boundaries of what you already knew had to be applied by Mendeleev, which he brings about in all of his writings. Okay, to speed things up, this discovery then allows us to start looking at the electromagnetic effects of the chemical elements. And with, Bunsen, Kirchhoff, the idea of spectroscopy became a new angle, a new dimension to which you could look at something which you'd sort of taken for granted after Mendeleev. People had said, oh, now we can know all we've known, right? We've reached a plateau of knowledge. We can't go any more than this.
What? Spectroscopy?
Spectroscopy, yeah. Have you guys heard of spectroscopy before? Yeah? Okay. Do you have any idea what it is?
Is it what's shown in the picture?
Sort of. I mean, what you're dealing with is that every element has a certain fingerprint, a certain color signature. And that you can only get when you take the idea of a Bunsen burner, right? Take an element, put it in a little heating element, and then create a certain gaseous, by heating it up, you release a certain gaseous quality to it. By then shooting a light through it and having a prism, you'll then get a little spread of light. And that light will have certain qualities to it. Like in the case of sodium, it'll have a distinct fingerprint signature of having two yellow bars that it emits or that it absorbs. Everything else is emitted. Hydrogen has a different quality, and that's you'll find all the way through the periodic table. So what is this getting us now? This is giving us new tools by which we can extend our senses to investigate things that we originally took for granted into not just the earth around us, but increasingly into the heavens. Because when you're dealing with now the effect of seeing how you can measure an element according to its electromagnetic signature, all of a sudden the question of what are stars made out of becomes very possible. Right? So now we could actually say that we know the general chemical composition of various star systems around the world. We can find that there are amino acids out there based upon their chemical signature in space. We could also say this opened up the door to life, because now when you apply this now to things like chlorophyll, we can discover what part of the EM spectrum causes plant life to grow. Right? And then you can and this is where the idea that really the plant isn't just eating light in general. There's a specific bandwidth of a small area of the spectrum which the plant absorbs. And this is the same for almost anything in living chemistry or non-living, but you do discover that there are these qualities. Cosmic radiation. Now, all of us, the Earth is all of a sudden seeming like a very, in a certain sense, tiny place, but in a certain sense, our idea of what the universe is expanding greatly, because Victor Hess challenged something which, everyone at this point had discovered what is like X-rays, gamma rays, radioactive decay. These things had all occurred due to Mendeleev around the period of the 1890s, all of it. And you have these huge outbursts of discoveries in the domain of radiations that are not directly observable, but that instrumentation could be created in order to make sense of and then applied in the form of X-rays, for example, to save people's lives. Now, this radioactive decay that people like Madame Curie had discovered, people had detected through Geiger counters, exists everywhere across the face of the Earth. Right? There's a small, what we call background radiation, almost anywhere you go. Even right now, I don't want to freak anybody out who's been brainwashed a little bit by propaganda, but we're being bombarded with all sorts of cosmic radiation right now. Don't worry, it's inside you. 1 billion decays a day. Keeps your smile fresh. Now, everyone was pondering, where's this coming from? And it was assumed for the longest time that it was really just coming from the Earth in some way. Now, Victor Hess says, okay, well, let's prove this. Let's figure this out. And he says, well, let's go to a higher altitude. Let's go to the top of the Alps. And strangely enough, rather than seeing that there's less radiation reaching their Geiger counter, all of a sudden they're realizing that there's more, paradoxically. Because you figure if you're getting further away from the source, you'd be picking up less, right? So they say, well, let's get on a balloon. That's a little hot air balloon. And sure enough, the higher up they go, the more radiation they're getting. To the point that we discovered through creating little cloud chambers on these balloons that we're being bombarded from every single source, from the sun to other galaxies to nebulae to to the Crab Nebula, with all forms of gamma radiation, beta decays, high-speed particles, and the Earth is just continuously being, compelled with these things. Now, because you have these filters, the ionosphere, the magnetosphere, and other things, not all of it is reaching us. There's a certain filtration by which life, the biosphere, is absorbing this extraterrestrial stuff. Now, another irony is that these things like the ionosphere and the magnetosphere and the atmosphere in general would not exist in the form that they do without the presence of life. However, life would also not exist without the presence of these spheres, these protective coverings. So what's the process that made that? Is it just happen chance chaos? Or is there actually a higher intention at work here? That's just the EM spectrum. So then to finish our little tour of the key discoveries in history before I get on with the point, this brings us to Vladimir Vernadsky, one of the key figures that LaRouche even brought up in this first quote as being core to understanding when we're thinking about the role of physical space-time as it's being expressed in the world around us, in the universe at large, according to a certain principle of distinct domains, of the non-living, the living, and the higher noetic domain, which we're going to look at a little bit more. And now in all three, I would say again, you're going to find a certain principle of a future state determining the present state, but it won't, there's degrees of freedom that we have to take into consideration. Because again, we don't want to just believe that the universe is organized in a good way, right? That we want to actually come to figure out how to know that that's true, so that we can't get demoralized by some green entropic idea that global warming killing us all. All right, so in the Biosphere, written in 1927, Vernadsky writes, Dave, could you actually read Vernadsky's quote?
Radiation from the cosmos throws an eternally and continually powerful stream of energy onto the face of the Earth, conferring quite a peculiar and novel character on the parts of the planet bordering cosmic space. Due to cosmic radiation, the biosphere acquires characteristics that are novel, unusual, and unfamiliar to the Earth's matter. The face of the Earth reflected in its cosmic environment shows a new picture of the Earth's surface as it is transformed by cosmic forces.
So I thought that was a big irony when we were reading through the Biosphere work, that right at the beginning, rather than talking about something that just sort of came out, the way it's treated today, right? Where did the Biosphere come from? People tend to treat this as some sort of epiphenomenon that's localized just on the Earth. All the conditions had to become just right, and then you had life that sort of sprang up when lightning bolts hit some mushroom or some precursor to a mushroom of inorganic material on the Earth. Then all of a sudden life blossomed randomly. And then survival of the fittest kicked in. So that rather than do that, Vernadsky starts from the standpoint of cosmic radiation and the cosmic context in which the Biosphere evolved into. And that's something very unique in his time. But this new perspective gave us an increased means of identifying these different phase spaces, which Vernadsky spent his whole life fighting for, which was getting people to understand that you couldn't just take a-biotic, lifeless chemistry and physics and try to describe something of a higher domain. You could just take life and try to figure out what life is by trying to break it down to small little parts to see how they interact. But you have to see that life itself is of a qualitatively higher nature intrinsically there in space-time, of a higher order of space-time that's acting upon, but yet unique to beyond simple, lifeless matter. Now, he went through, this is where I said briefly, and I mean, some of you may have heard this once or twice, but this is where the idea of the noosphere, the biosphere, and the lithosphere kick in. Because we're dealing with atoms everywhere, right? There's atoms from the periodic table of elements that make up everything that we're seeing. But what's different is that there are distinct qualities to how they're being organized. Just a few. Like, one thing is that he points out is that a discovery by Louis Pasteur is very important in the sense that when you look at life, living matter, there is a certain asymmetry to it that you don't find in non-life. In crystals, there's a relative, just perfect, symmetry. Or like gold will tend to grow as, they'll tend to grow as cubes. You'll find general, perfect, more pure symmetries occurring in non-living matter. But all of a sudden, you start looking at matter, and what Louis Pasteur proved, and what Vernadsky fought to bring back to the surface, is that when you take polarized light and you shoot it into a solution that contains living matter, that living matter bends or rotates the polarized light. And he was using tartaric acid, which is we made a whole video on this, it's quite good. But not just that, you're dealing also with a certain capacity to transform matter and energy to an increasingly greater power of rate of change. you have obviously matter becoming energy in the course of uranium decays, all sorts of radioactive decays. That transformation is happening, no doubt. But then when you start looking at life, all of a sudden these transformations that would normally take millions or even billions of years are speeding up in front of our eyes in the form of milliseconds or less. So Vernadsky pretty much creates a new science called geochemistry or biogeochemistry. This is something which, again, Marusha said that if people want to understand physical economics, we've got to go back to this guy's discoveries. It's vital. Which brings me to my main point. Now, electromagnetism provides us a certain venue by which to investigate everything. But more so, I'm going to see how this is something which Vernadsky points out also as being very important, and all great scientists tend to, which is one, acknowledging that everything that we see around us is in a state of change. That's something which is directly observable. Things are changing all the time, but they're not changing in a chaotic way. Things are changing according to certain invariants. So there's always a variable and an invariant happening at the same time. One of the things that we'll find is that in each of these three phase spaces, electromagnetism occurs. You're going to find electricity, you're going to find magnetic fields accordingly. But how they're operating on this system, the changes which occur in each system, are what we really want to flesh out. So I figured what I would do here, just be a point, and really this is something people really take way too far. And they just say, everything is changing. It's right up there with people who just like take Einstein's relativity and just say everything is relative. And it's like, have you actually read Einstein? there's a higher reason to what he's saying there. But yes, things are changing, but you've got, I would challenge anybody, I've been thinking about this, but I couldn't think of any type of change that I could think of that doesn't fall into the categories of what's just mentioned here. If anybody can, please tell me. I would love to know. But I think this pretty much qualifies every possible type of change you can imagine. All right. So you got place, things are transported, and you got form. The quality of a state of existence. Oh, substance. You're saying like substance change?
Yeah.
I'm using sort of form in that type of.
Okay.
Yeah. Okay. So I'm going to use Ørsted's discovery here of electromagnetism, because this is sort of where the root discovery takes off of magnetic fields as such, and just try to illustrate. Well, first of all, what exactly he did, because why it wasn't thought of as this is the way these discoveries work sometimes. What's the most simple possible resolution to a problem is the last thing considered by people who are just they make their lives way too complicated, trying to piece together different theories and opinions, but then not actually looking at the phenomenon itself. Because for 20, 30, 40 even years, right, close to 40 years, it was, and I mentioned this at the beginning, but it was totally determined as a fact that magnetism and electricity, no commonality. Yes, they both have attractive or repulsive qualities, but no, you can't link them. And then Ørsted in 1812 has the idea of taking a compass needle, taking a current in a copper wire, and then observing how the needle changes. So all of a sudden he discovers that what was once aligned parallel to the current rotates to become perpendicular to it. And you could then create certain contraptions with various compi around currents flowing upward or downward to see just in what direction this hidden field is actually moving, since there's a certain geometry to this space. They say this domain is a sort of like the first degree of freedom in a certain sense. Here, I found these two really ratty magnets sitting at the office. But if you think about it, the entire potential, if I bring them together, technically you could say that their field is spread out as far as you want to go, but there's a certain point where it doesn't have any effect anymore. But if I bring them together and hold them at a distance where I could feel that they're pulling onto each other, okay? Oh, see, they're working. They're pure potential energy. It's not kinetic energy. So I could say that as soon as I let go of my hand and turn that potential into kinetic energy, its entire destiny is shaped according to something physical that's expressing this field. Right? The magnetism is not the magnet. Magnetism simply requires a material character by which to express itself. So the entire destiny is determined according to a principle of... Oh, shit, that kind of hurt. Okay. So according to a certain rate of change, an acceleration, their entire actions are already determined in the present, according to a present state, a present configuration. And in this sense, it's really no different than the basic laws of gravity. If I throw something of a similar sort off the table, its acceleration is predetermined. It's going to move. It's attraction. The attraction to the source is relatively. You could guide it by the inverse square law. So if it's 2 feet away, the force would be like if the object is 2 feet away, and another object is 1 foot away, that one will be 4 times less than of power than the one that's 1 foot away. So the acceleration will be much less, and as it's closer, it'll accelerate according to this inverse square principle, like law, which isn't really it's not a formula. I don't want to throw formulas at you guys, but it's just a deterministic quality. And you'll find that, I mean, even going down to the microscopic domain, there's a certain predeterminism. Now, human beings, when they try to shape their imaginations and their intentions according to that domain of the a-biotic, they tend to act a lot like a Barack Obama or some other budget cutter who will say, the forces say that we have to act this way. The market forces say that we have to print infinite money to bail out toxic debt, or else the forces will be angry. The gods will be angry. Right? So their behavior is being shaped by a conception of forces which they have no will or ability to participate in changing. And this is generally the domain of the pure mathematician, in terms of their ability to move their mind outside of a fixed boundary condition. Okay. But all of a sudden, those things break down because when you start getting into the domain of life, not only are you realizing that the basic laws of gravitation, of electromagnetism, don't function the same way anymore. Right? Even the existence of a tree which grows is already, by virtue of its action, disobeying the basic tenets of gravity, where a rock will simply just fall to the lowest, it'll fall towards the source of that which attracts it. A tree, well, that's something which is very small, very, very, very tiny as a seed, but yet the fact that it moves away from this massive attractive force of the earth is displaying something that disobeys all ideas of, forces attracting each other at a distance. That the one force will be attracted according to the inverse square of the bigger body. But life itself is exhibiting this quality, a tendency towards also increasing complexity. And what I thought would be very useful would be to investigate how these biomagnetic fields express themselves, or how magnetic fields express themselves in the domain of life, but from the vantage point of the large. So the idea of species, by looking at one species that change their position and their form on the Earth. And on a smaller level, what makes up an individual of a species. Right? So we've got an accumulative quantity of cells which also are continuously dying. New ones are being regenerated. And you got this continuous flux of motion, which Vernadsky points out is what's called a dynamic equilibrium. You've got a constant motion of new cells, new material coming into us through food, leaving us through other things that you all know about. And yet there's this continuous identity, even though all of your cells have transformed multiple times. Every 7 years, you're dealing with even new bone cells. Everything about you is different from it was from 7 years ago. So even though all the material substrate of living organisms is always in a continuous flux, there's something that's remaining constant. There's the biogenic migration of atoms, which is another important element which is completely ignored in biology classes today. So on the cellular level, you can't just say, oh, well, the cell is really just a composition of molecules, which are a composition of atoms, which we all know are just random and unknowable because they can be sometimes a particle and sometimes an electron, sometimes a wave, and so it's all just chaos. Which is tending to be the case of how people tend to treat this today. That life is somehow just the sum of these inorganic, chance phenomena. But when you're dealing with these cells, which is sort of like the smallest part of a human, when you've got certain electromagnetic fields that occur, which, if you didn't take them into account, it would really be absurd to try to account for how one cell, takes over the function of another cell after it dies or is replenished, or how an embryo even develops into a baby. And this makes a lot of people very uncomfortable. A lot of reductionist biologists get very, very uncomfortable by this fact, of the fact that we all come from single cells that develop into fetuses and become little human beings. Because you're dealing with something that challenges the fundamental tenets of purely mechanistic Darwinian philosophy. Right? Where Darwin would say the only way we'll allow creativity, like new creation of new states of existence, is through what? What's the mechanism that causes that to happen? Anybody can guess? Yeah, your ability to have a better way of...
Get one on your neighbor.
Yeah, get one on your neighbor, exactly. All of a sudden, who's the fetus fighting with? And yet you've got new points of creation. There's speciation of cells that take on at a certain point a whole new function that hadn't existed in prior states. Certain points of development of transformation, which these are creative acts that are occurring. And yet there's no jungle occurring in the womb. It opens the mind in a very clear way to thinking again about the idea of both freedom and destiny. Because it seems as though that this single cell, this little zygote, on the first day, is moving almost with the finished product in mind. That finished product is organizing the unfolding of the embryo, right? As it moves into a blastomere, it moves increasingly becoming more complex. But it's not predestined in the same way that magnet was. Space-time is different. We're dealing now with a different domain. So what you have, this was the battle that was occurring in the late 1890s and into the early 20th century, was over these two ideas of whether one is all of the information of what everything will become locked up as a blueprint inside of this first cell, or is there a capacity for change? Can at any point in time along the embryo's development, those cells become something else? Right? And this is what was called the difference between epigenesis and preformatism. Preformatism means that it was all blueprint, it was all predestined, there was no freedom, it was just there. And then epigenesis was the opposite extreme, that everything could change at every given moment, and you could only know one moment ahead and one moment in the past what the states were going to be, but you couldn't know what the cell was going to become or move towards, 5 steps down the way. Kind of like the statistical forecaster today, who tries to make a forecast of what the next quarter is going to be, but they're always wrong, or the weather forecaster too. Next week's weather, it's not going to happen, you won't know. You can't know, because all you have is statistics. But what we found was that neither one of these people were really looking at the electromagnetic qualities, partially because not a lot of people knew about them. And a big question was, where will the axis form? Because when you're dealing with the first cell, there's no distinct qualities to that cell yet. So every single organism has a certain physiological, right, symmetry. All animals will have a certain symmetry. But where will those arms be? What will determine where the tail, where the arms, where the head, where the spinal cord, where's that first, what determines that first sprouting, right? And that was a big point up until the 1920s, when it was discovered that there was, by finding a way to measure the ionic currents that are moving into and out of the embryo, inside of a solution, that each embryo emits a certain electrical current, a certain magnetic field that goes with that. And what they found was that rotation is what then determines the axis by which the entire organism will evolve around. Now at this point, yeah, okay. No. Yeah. I'll mention this very quickly, because I think it's important. It wasn't until the 1920s with a friend of Vladimir Vernadsky that the discovery was made that these cells are coordinated according to certain electromagnetic emissions of light. You know what? I'll put a pause on that. I'm going to go back to that. Because the first question really is, all right, if we see these things unfolding, the embryo is growing, what's determining what the cell will become? And what they found was that by simply taking the cell at the second blastomere stage, where you have two cells, and separating them, that you had two organisms form. These were chickens. So this seemed to prove pretty concisely that these cells had a certain freedom to become something new. That it wasn't all locked up inside of the first cell. Right?
You're saying that the first cell, it divides a bunch of times, so the first division.
The first division, when they separated,
took them out.
Yeah, they discovered that both cells took on the functions of becoming a fully formed organism. And other experiments were affected on this, which had people moving certain cells, chopping certain cells off of the embryo, and then watching them recombine. And you discovered that even up until like the 32 embryo stage, or 32 cell stage in the embryo, by taking what would normally become the head and detaching it from what would normally otherwise become the lower part of the body, and then moving it, like flipping them around, that the destiny of those cells had changed accordingly. Their context had redetermined their speciation, their differentiation of what they would become. So that says a lot about what is the creative element here in the mix. It's not like they were completely determined what the magnet was by a certain future state. But there was a certain level of context now, and a certain degree of freedom. This got a lot of people to ask increasingly, well then, what about things that we see pertaining to a fully formed organism? And there's certain animals like these newts, where if you cut off one of their limbs, a whole limb is going to grow back, fully formed. You get it in starfish too. You chop off the starfish limb, it's going to grow back. There's a variety of these very interesting organisms. And one thing that they found is that the cells behave in a very interesting way. That as soon as you chop off the limb, you have a de-differentiation, like all the cells that were normally muscles or nerves, de-differentiate, and they become kind of like it's called a blastomol. No, it's called a
Stem cell.
blastomol cell. It's kind of like a stem cell. It could be anything. The damaged tissue is taken away, right? Kind of like a little construction agency goes to work. A little epithelial cell forms over the wound. And as soon as that happens, it's like a little thin cell. This happens when you get cut. It's like a little thin skin. As soon as that happens, then all of a sudden, over the course of 9 weeks, you have you have all the individual cells falling into place and taking on the job that they need to do to fulfill the function of the arm. And now this team that had discovered originally the electromagnetic currents, the ionic currents that occur around the cell, which determines its axis, went to work and found that even indeed in the limb, as soon as you have the epithelial skin which forms over the chopped off limb, that there's an immediate high intensity of electricity that occurs flowing out of the wound and into the accompanying flesh on the side. And this intensity exists for a certain amount of time, and then at a certain point it flips back in the other direction. Now, by taking this, the frequency of this current, what they decided to do was then, and these are the group of people in the 1970s named Lionel Jaffe, Richard Borgens, and Ken Robinson at Purdue University. What these guys did is then try to take the intensity of the magnetic field and then apply that to animals whose limbs don't normally regenerate. A frog doesn't have the ability to regenerate its limbs. As a tadpole, it kind of does, which is a weird thing about amphibians. You chop off its tail, it'll tend to grow back a little bit, but at a certain point when it becomes the fully fledged frog, that leg, when you're eating frogs like legs at the Chinese buffet, there's no frogs hopping around anywhere. they're in wheelchairs.
That'd be nice.
But so what they did is, and cruelty to animals aside, we'll leave that at the door for now, but by putting little electrodes inside of the under the skin of the frog, they were able to induce certain currents which stimulated the growth of the cut-off limb's tissue, thereby approximating in a certain effect the regrowth of the limbs that you can see in the newts. Now, while this did accelerate the growth, as you see here, you did have a certain growing occur that was induced artificially. It was a bit of a mess. You had a complete undifferentiation inside of the tissue. There was nervous tissue all over the place, muscles. Like there was not a very formed structure underneath there. But regardless, this did set us in a certain direction in our ability to then think about what are the implications for actual, limb loss in human beings and other things. If it can exist in one part of the biosphere, then why can't it exist if the correct methodology is applied and discoveries made? Then what could this say about our ability to regenerate limbs in some point in the future if we get real science back on track? Now again, this is the current density. When you're looking back at the embryo forming, there's two important stages. On the one hand, you have what's called here the neural tube that forms it's sort of like at a certain point in the embryo's development, it's sort of like a clam that sort of folds over onto itself. And this is called the neural tube. That folding in that every embryo goes through is what forms the brain, the spinal cord, and this is going to be the central nervous system. During that time, a little bit afterwards, after, right? After, yeah. You have the posterior intestinal portal, which is the basic gastral area of the embryo, of the baby, what it is at the beginning. And the two currents that they found is that, in this case, where you first have the first sort of chibe, at the first moment, at the first indentation, you have a negative magnetic current or electrical current, which flows into the embryo, and then all of a sudden there's a point of transition at the 15th stage, whereby all of a sudden it moves outwards to a certain peak at the 17th, whereby it then starts moving down. Now there's a constant process, but its quality is changing according to a lawful process of the unfolding of the embryo. Similarly here, what they found is that the intensity was always greater around the actual mouth of of the neural tube. And there's a gradient of a certain sense of loss of intensity as you move down. So it's not like you see these images of magnetic fields, and it's often this very homogeneous, idealized sort of torus, right? No anomalies, no qualities to it except just pure sphericity. But in reality, what you're dealing with is something that has a highly structured process where there's no 2 points on it that are exactly the same. So if you're thinking, well, what do the cells have to navigate by? What are they measuring? Is it just like empty space that they're just attracting themselves to, and then talking to each other through, shooting off DNA and is there just pure chemistry at work here, where each one is communicating to each other through basic, genes talking to each other, or are there these higher fields that are at work organizing how they're behaving and interrelating? That's where it gets kind of fun. Going back to Burbage, because this is the guy who demonstrated two very important discoveries. One was the ultra low, ultraviolet frequencies that each cell emits in pulsations. So if you're asking how do they all regulate, every single one of the cells in your body is, every time it mitosis, every time it splits into two, or rejuvenates, is emitting off a small burst of light. This is ongoing. Now, there's certain fun experiments that Gurvich used to prove this, and that others who picked up his discovery in the 1970s, which was, his discovery is almost buried for like 30 years, but when they picked this up in the 1970s, they found that there were interesting things you could do with fish eggs by measuring the ultraviolet, the low, ultra-weak ultraviolet frequencies, that when you separate them by a form of glass or quartz that permits for UV radiation to permeate it, that one which may be very much younger than the other, there are two different stages of development, the younger will speed up their growth process to catch up to the older ones. That's funky. But at a certain point, if they're too old, what you find is that the young ones are then inhibited from growing. They come out like mutants. So you have an immediate regulation occurring through the emission of these, what are called it's photon sucking. It's like these little pulses of light which are just eaten up by each other. But then on a more interesting level, what Gurvich proves is that you have what he calls the dynamically preformed morpha. And so what he discovered is that by looking at the alignment of the cells, taking little cross-sections of the cells in plant life and other basic simple life, you could see that according to, like these are their axes, it doesn't really show up very well here. Maybe this one shows up a little bit better. Like you see these axes are all very closely parallel. I don't know if you guys can make that out. Sort of. Yeah. These ones are not. These are very much more chaotic. What's discovered is that the degree of randomness is increased based on the degree of distance from the surface area of the organism that they will become in the future. So you take two stages of an embryo or a young plant growing in time, and that future time, that future surface area that doesn't yet physically exist, is actually exerting a measurable force organizing the change of the current state. That's funky. So you do have, right? You do have obviously a certain future determining the present, which you could get relative forecasts into future states in weeks, even maybe a couple of months ahead of where the organism is going. And Gurvich proves that there's a relatively high probability that you can score looking at what the organism will become based upon this discovery. But you can't go so far ahead that you can discover what it's going to be in a year or two. Right? There's a certain limitation. So there is an organized field that's determining the future outcome, but it changes at every moment. So if I cut that leaf, if I intervene from the outside to change that process, that might change. So it's in a certain sense has a certain pull according to a present time, but if any change occurs, a new future surface area will come into being, reorganizing the current conditions of those cells in the present. Okay. All right. So now looking at the higher domain, which we're more used to with our eyes, every animal, and this is what JP went through at the beginning, right? Every single animal that we've investigated senses and acts upon the magnetic, or acts according to the magnetic field fluctuations of the Earth. And that accounts for animals when they fly south for the winter, species of fish that, I mean, all of these animals navigate according to this field that can't be seen, but that they sense. We don't know how exactly they sense it, but there's ways of investigating it. In certain instances, like this kid here, what he's looking at, I don't know if you guys have seen this picture before in the news. That's about 6 tons of anchovies inside of a port in, I believe, Florida. But what you're dealing with are animals that are simply responding to anomalies that are occurring in the magnetic field of the Earth, which we know is directly connected to things like earthquake, volcanic phenomena, the sun's intensity, which has an effect directly upon scrambling the atmosphere and all of these geomagnetic fields. So for the animals, I mean, they don't know what's going on. They're just acting according to their nature. But human beings, if we're paying attention, and this has been proven in ancient Chinese records, when you see the animals behaving all wacky, like JP was saying, you get out of town. You know something is going to probably occur. At the very least, you don't ignore it. So we know that life evolved according to these fields. Now, there's some interesting. Just like the magnetic field of the embryo is not homogeneous, the Earth's magnetic field, even though you see these awesome pictures of it being bombarded by solar winds and stuff, looks very cool, it's not homogeneous either. There's all sorts of fluctuations. Oh, heavy? Why is the thing?
Close it in.
You okay?
It's on the desktop. No, it's on the desktop.
That's not this. What do you mean? Yeah, no, I was just going to do this. Open it. Was it?
Utiliser la technologie des fois. Hein?
Des fois, yeah. Okay. So the number that you're seeing is the year, and where you're dealing with the changing lines is the inclination, the magnetic inclination of the Earth. So the inclination is basically just when you take the compass and you bring it to the equator, it's going to be completely parallel to the surface of the Earth. All of a sudden you start moving up, and then as you move up towards the North Pole, you're going to see that compass, if it's a free-flowing compass, right? If it's imagine like a compass in 3D, not just bounded in a little flat surface, but if it's in 3D, capable of going anywhere, as you move up increasingly, you're going to have it spin to the point that it runs parallel to the geomagnetic axis of the Earth. So when you're on the geomagnetic North Pole, it's going to be pulling itself straight down. Similarly, when you walk around to the South Pole, it's going to be pointing straight up. At the equator, it's completely parallel to the Earth's surface. We call that inclination. Declination is the other image, but that's, to point it out, is when you're dealing with now a compass. You could leave it on your compass plane. It's like a little circle, right? And it flows around in a circle. As you're moving around the Earth, let's say you're in France and then you move all the way to New York, there's going to be a changing angle that occurs between, like, if you point at the the geological, like the geological North Pole, where the axis of the Earth really is, and then the actual magnetic North Pole, they're not the same thing. They're about 1,000 kilometers apart. So there's going to be a certain angle that's created when you point to both. Now, actually, a better way of illustrating it, right now, if I point to 2 points on the wall, right, my angle is very, very tiny. Like the angle between my arms is very tiny. And as I move closer to them, the angle gets bigger. Right. So as you're moving up towards the two spots, that angle decreases. We call that that's what's called declination. So these things, over the course of long periods of time, I'll show you what the declination looks like. See along here, there's zero difference between these poles. Everywhere here, there's 20 degrees, 30 degrees, 40 degrees difference. So these are, over the course of a couple hundred years, these things are changing quite visibly. Now, in this time, species of pigeons, most of the species that we see today, except for maybe the dodo and a few others, they exist throughout. So there's something which has to be communicated from one generation to another that permits that new generation to not get completely lost from what the parents taught it. Like the parent taught you how to use a horse and buggy, all of a sudden you're in a world of cars, and obviously you don't know how to use a horse and buggy anymore. Or you don't know how to use a cart, but you've been trained to think about horse and buggies. That doesn't happen with animals. There's also not just that, but in the course of this general trend of transformation, as the geomagnetic axes are moving, because these changes are determined by how the geomagnetic axes are rotating, are moving around. On top of that, you have, at every step of the way, solar maximum, solar minimum. You had a little ice age there for about 100 years in the 17th century with very little solar activity. And you have these various field fluctuations that are happening all the time. And so throughout this process, these species are going to go extinct if they don't have something within them that permits to navigate accordingly, right, in their general seasonal migrations. How do I get the slide? No. Shit. Yeah. Sorry. There's a lot of these things. All right. Oh yeah. I'll just point out that some of the anomalies that exist, like when you go around the surface of the Earth, the things that will make these anomalies are things like high densities of iron, magnetite, any type of magnetic mineral inside of the underneath the Earth. Like if you go to Kursk, Russia, that you're going to find that the amplitude jumps 4 times in terms of the magnetic field. And Finland, you got the Bermuda Triangle effect, right, where all of a sudden people go into these certain pockets and regions around the Earth, and all of a sudden there comes go haywire and ships disappear and all sorts of things. It's not aliens under the surface like a lot of Hollywood movies have shown. There's reasons for these things. But you're dealing with these anomalies. You're also dealing with things like power lines, cities. Pretty much everything human beings have done since Benjamin Franklin made his discoveries by harnessing electricity and bringing it into usage emits these fields, some more strong than others. And so these are all variables that have to be taken into consideration in a certain sense by the bird without being self-conscious about it. And just to show that there are some fun experiments that have begun being done in the 1970s. This is a relatively new field of science, but an important one, pertaining to what is it about these pigeons and these other nightingales and other things that permit them to navigate. And what they found was that they could artificially create magnetic fields and change them in the context of where the birds were migrating, such that by changing them by 120 degrees, for example, So creating an environmental condition where the field was shifted by 120 degrees. All the birds, instead of normally migrating north at that point in the year when they had that impulsive urge to do so, all of a sudden went southeast. They continued that again to go, right? They continued that through the south, and they did it again. So that was the first, in a certain sense, experimental proof that these birds are navigating according, or seeing, experiencing in some way the magnetic field. Turtles too. You got these interesting loggerhead turtles, which have this interesting quality that the mom's plant. They lay their eggs in the sand of the beaches, and all these little turtles go for a mad dash for survival at a certain point of year to try to avoid being eaten by all these birds. They're just standing there waiting for them. And there's millions of them that just rush into the ocean immediately. And in the course of their life, have a certain migrational nature where they maintain themselves in what's called the Atlantic gyre. And so these hatchlings continuously, they don't go too far north, they don't go too far south, they don't stay within this area. And again, by applying certain magnetic field fluctuations to a control group that accord to what the magnetic field on the Earth is in each of these three places, they found that indeed the little ones would always coordinate themselves according to that field, where they would normally be going if they were in the real ocean. So turtles do it on a very regular basis. Oh yeah, there's also another interesting quality as well. They use these European pied flycatchers. I don't know, I've never seen one of these, but they're a European bird, and they seasonally go to Arabia every year when they fly south. Now, what these things do is, at a certain point, they just don't go south immediately. They have a certain quality where they can tend to locate the physical topography of the Earth and change accordingly, change their behavior accordingly. So at a certain point, they'll just make a 90-degree angle to avoid the Swiss Alps. Then they'll make another 90-degree angle to avoid the Sahara Desert. And then they'll go there. They'll even eat more. So before they get to the Sahara Desert region, they'll beef up and double their weight. So that there's a certain, even hatchlings that have never experienced that journey before, beef up. They have a certain thing ingrained in them that shows where we have to eat a lot, where we have to turn right, according to what constantly changing field fluctuations, which is, again, it's pretty mind-boggling when you think about what must be happening there. And so the only thing that they could find was that the commonality between all of these animals, when you're trying to figure out what exactly is allowing them to do this, because they found that when you cover like their right eye, all of a sudden they're lost. Like most of these birds, if they're adult birds, by having their right eye covered, can't fly. They're all discoordinated. Cover their left eye, they can fly just fine. That was an immediate strange thing. But the turtles and other animals, not the case. You could cover both eyes and they would still navigate just fine. So the common invariant in all of these species is that they found that there was a certain substance inside of the beaks of the birds, but it's found in every single bacteria, invertebrate, everything, which is magnetite. It's basically what the ancient Greeks called lodestone. And this forms organically. It's not the same type of thing you would find growing in that you dig in the earth. But it's a certain quality of it, which grows inside of the beaks, inside of the skulls of the turtles, inside of you. Apparently there's certain quantities of this magnetite. And indeed what they found is that by tranquilizing the beaks, that these adult silver eyes, which are a species of bird, were completely discoordinated. So that was what they did is they shot a little magnetic pulse into the bird's beak so it couldn't feel its beak anymore, couldn't fly. But again, paradox. All of a sudden, the ones that were just brand new babies, never experienced the migration in their lives, they had their beaks shot a little magnetic pulse. They navigated pretty well. So they weren't really affected. So the magnetite, then we know it's not something which is causing them but it's helpful to them to navigate. So you wouldn't attribute causality to it. There's a higher phenomenon. Kind of like the magnetic field when it spikes before an earthquake, or when you have the magnetic field fluctuations spike, it'll usually happen right before, during, or after an earthquake at a very high intensity. But the fact that it sometimes happens after, what a lot of people say is, okay, thus that's a cause of the earthquake, right? Because we know that when the sun has a lot of activity to it, we could make a statistical correlation and say when the sun has a lot of activity, the magnetic field has a certain spike, and a lot of people jump the gun and they say, okay, that caused it. But then that doesn't account for how sometimes that magnetic field fluctuation happens after the earthquake, meaning that there's yet a third higher cause outside of simply the sun. Right? It can't just be the sun. It has to be that there's something outside of the solar system which is still acting and impacting activity here on the Earth. And it's sort of a similar principle that you'd have to take on. You don't want to jump the gun when you're saying, okay, well, thus the magnetite is the cause because it's found everywhere. But there's yet something still higher. So what was it? Well, these guys these scientists did these experiments just this decade. And they started investigating different frequencies of light. And they found is that these birds, when they had a light of ultraviolet all the way up to green, their navigation was relatively unhinged. You see, all of the birds, except for a couple of lost ones there, were generally moving in the according northeast direction when they were supposed to. But all of a sudden, you get up this spectrum into the yellow and red frequencies, scrambled. So this raises just more questions. Why is that? What's causing this? And what they found is that there's a certain pigment, and this gets at, again, how does chemistry also interact with all of these electric fields? But there's a certain pigment inside of the eye which picks up which is directly affected and sensitive to the blue spectrum, whereas the red has no effect. So currently that's the best hypothesis so far, but we still need to go further. In all of this, though, you're seeing that you're dealing with changes of place so far, the migrational patterns of birds, right? This is the change of place, but then you still have to deal with the fact that the quality of the form changes too. Not just from the young bird to an older adult, but you're dealing with the species as a whole over these long cycles. We call it evolution. So as the species themselves, new species come into being, what's organizing this? And again, you got to get the Vernadskian standpoint, right? Out of the world of Darwin and into the world of cosmic radiation, you got to situate the context in which this life is occurring. And we've got a sun, which has a certain quality to it too, pertaining to what it's shooting at us. And Vernadsky, when he starts the biosphere book, points out that we're receiving, on average, about 4 octaves of light. One of the visible spectrum, of 400 to about 800 nanometers, about 2 in the infrared, and 1 into the ultraviolet. And this is the majority of what the thrust of what the sun is shooting out of us. Other star systems have other spectrum, but this is the sun. So the fact that our eyes pick up the intensity, this visible intensity that's of the greatest magnitude in the sun, is probably not a coincidence. Probably had a lot to do with what tuned the development of life here on the Earth. Right? What determines what these species will become. Probably has a lot to do with these frequencies as well. And this is the sun and just 4 different filters from. Yeah. So this then raises the question. Okay, so we've seen how how time is behaving differently in physical space in the lower 2 domains of the a-biotic and the biotic. How the future is increasingly determining the present, but yet with higher degrees of freedom. But then, what about human beings? So we know that we have some pretty unique characteristics to us. We've established that throughout the course of the presentation, and probably a lot of you guys have intimated that in the course of your lives. But what do we have to take into consideration as true variables when we're organizing our destiny, our future? Well, there's certain interconnected processes, the sun just being one. But we also have phenomena that we have to really plan for. And you need a space program. You can't have a free trade or an empire which is running society if your society is planning for things like we know happens occasionally, such as these pole reversals of the Earth. We know 700,000 years ago was the last pole reversal that the Earth experienced. We know that these things do happen periodically anywhere between 40,000 or up to a couple of million years. So these poles, we don't know exactly what happens, but we know that we want to understand that before it does happen. You don't want to be caught off guard with something like that. So right now, we know also that the intensity of the pole has been of the geomagnetic field has been also reducing itself over the past 100 years. Does this mean that we're going to have a pole reversal in 2012? Not necessarily. No, I mean, in all likelihood, no. But we should definitely be prepared, since either us, our children, or grandchildren are going to have to deal with whatever vulnerability the Earth will be in when increased, coronal mass ejections and other gamma rays are bombarding the Earth at those points. Do we have a way of influencing such frequencies the way we influenced the growth of the frog's limb, right? Or the way that we were able to influence the geomagnetic fields that organize the migrational patterns of these animals? How would the increased salinity? Think about this, right? If you create no WAPA, then by bringing down some of the fresh water that normally flows into the North Arctic Ocean, which should have been already done 40 years ago, but by bringing some of that down, all of a sudden you're creating an enriched, dense, saline substance in the North region. We know that salt, sodium, saline is a very conductive ion. It's positively charged. It has certain effects that relate to the ionosphere, to the Schumann resonance. We also know that we're on the verge of an ice age. We're way overdue. So at a certain point, the ice goes down below a certain breaking point where it can't compensate over the course of the next season's melt. Then you have an ice age onset. We've already been in an ice age for quite some time now, like 2 million years. So this is one thing again in which how would that increased salinity in the north affect perhaps even keeping these ice caps at bay, or influence things like the geomagnetic field of the Earth? I mean, we got to get beyond though this false dichotomy that you have in this debate against the right wingers who are pro-free trade and monetarism versus the radical leftists, like who are the environmentalists. One of which who says, "Oh, man's activity on the Earth has no effect whatsoever. Right? It's all just, we should just be making money, drill for oil, right? Turn that oil into money as quickly as possible." Which is what you get out of this neocon point of view. Man has no impact. To the other extreme, which is that, yeah, man has an impact, but that everything we do is destructive as hell. There's nothing that humans can do that are actually potentially positive for the biosphere. So you have this false dichotomy. The truth lies somewhere outside of both. But again, we're only going to be able to really make these breakthroughs when we shed ourselves of the riddings of a lot of this mechanistic doctrine that keeps us enslaved by an oligarchy. The extinction cycle here is also what I brought up at the beginning. As the Earth flows through as the solar system flows through the plane of the Milky Way, you've got a certain extinction cycle where you've got these spurts of new species coming to being, but you also have these dips periodically too. Right? The last big dip happened around the time of the dinosaurs. So this raises the next question, which is, right, are we as dumb as the dinosaurs, or can we get around this? So these are all phenomena that we're just scratching the surface to right now. But I figured that the best way to leave it would be from a brief quote from Hans Christian Ørsted, who discovered electromagnetism. And by reading the original writings of actual discoverers who contributed to the growth and progress of humankind, rather than just reading about them from people who probably didn't even study them, it shows you that there's a certain common intention and spirit in the minds of these people, which gave them the courage to fight, in most cases, for political freedom as well as scientific freedom of the society as a whole, against all odds. And it's always been the minority. It has never been, in any case, the majority of scientists who just make a common discovery, or it's immediately adopted. But Hans Christian Ørsted is a good figure in this, who I think would be worth reading. Can I get a volunteer? Okay.
The process of thinking according to its nature must act according to the eternal laws of nature, so that its unreasonable existence contradicts to its fundamental essence. There is already located an urge there to weaken the power of evil within the willing person himself. Therefore, we must assume from all that has been said that the human race develops itself according to the laws of reason, and that the series of changes which take place, despite alternating between progress and decline, lead to actual development, and that the intervention of free will, notwithstanding apparent disturbance, must obey the internal order of reason. We must remind ourselves that centuries are short periods in the history of mankind. As Christian Ørsted, his spirit picture.
So, it's with that we have to really recognize that what we're bringing back is the question of what is the purpose of anything, the purpose of science, the purpose of life. This is a question which has generally been banned from the discussion table. You can't ask that. It just is. Right? This is the chaos theory explanation of the universe. This shit happens. It is that way. You're lucky. Right? Don't ask causality. It's all random statistical interactions in the small that cause seeming order. Don't ask why something happens. So the opposing idea is that the actual principle that guides a human being to dedicate their concentration span and their courage to truth beyond everything else is what has given us every inch of progress that's been fought for in the continuum of who knows how long humans have been on the earth. And this is what we have to bring back, because in a pessimistic culture of existentialism where people say, well, what's the purpose of a human being? Well, get your kicks and then you're out, you know? It's this very sense-based, materialistic consumer culture that's been created as a matrix for us to adapt ourselves to. There's no free will permitted if you actually want to think about a future. But also there's no chance for happiness unless you're willing to think about a future. Which is why you tend to get this crazy Montreal nightlife and, you know, people going into massive depressions all over Quebec and around the world. Because it's a trap. It's a trap, and the free will it reacts in a dissonant way to suppression. The human being wants to live by its conscience. We want to develop. We want to know truth. That's every child asks why. So bringing back the question of why do we have science? Why do we have humans? Why did the universe produce us 2 million years ago while we're about 2-3 million years overdue for another mass extinction cycle? Do we have something to think about there? Is that a chance? Is that just happen chance? And I'd say when you look at the potentials that are before us right now, looking at what people like the head of the Russian space agency has proposed to the world as a means of having an alliance of sovereign nations to build high-tech space programs and satellite systems to investigate the precursors for earthquakes based upon intergalactic phenomena. And you look at what China's been proposing as well by taking the lead in a lot of these fields. You realize that the flank is there. The oligarchy is bankrupt. The British Empire, their banking system is finished. It's just a question of when it's going to pop. What's necessary now are the ideas, because you can have the Glass-Steagall, you can have all of these nice mechanisms like a New Bretton Woods with fixed exchange rates. It's all been worked out. National banking, Hamilton laid it all on the ground 250 years ago. Every time it's been applied, it works. Nations don't have to submit to the rules of a free market. However, if you have all of these mechanisms in place, and you still are caught in a society that's building windmills, you're going to kill off everybody, nonetheless. You need a society that is unshackled from all of these false paradigms of what is it required to sustain a growing human population and deal with the unfolding, threats that the universe does pose for us, that we should optimistically look at and say, all right, how do we produce a more creative generation, next generation, that can make even more Mozarts and Beethovens and geniuses than we had in this generation? And have that as your standard of value. Right? And this is where you get at the idea of space-time again. The future's pulling us. The future pulled all you guys into here. A future idea, when you got out of your house, was organizing you putting on your clothes, deciding where you were going to go. Right? That future intention is what organized all of your unfolding actions on a small scale. But now extend that, right? Think about, as a nation, are we building hospitals? Are we building infrastructure for a few years ahead? Are we building them up for 20 years ahead? What about the next 5, 8 generations? Is an intention that's penetrating deep, deep, deep into the future, based upon the experience and wisdom gained from penetrating deep, deep, deep into the lessons of the past, informing our present actions by putting a young woman on Mars by 2040 or 2050. I mean, the Japanese have that intention, but how do we use that to resituate how human beings change physical space-time? And I think I'll leave it at that, because this is what we have to work through. So if there's any questions, you don't have to clap, it's okay.
I wanted to start the clap.
I was going to say that this idea of cognition without humans, or reason without humans, is very provocative. Was there reason before there was humans? Or is it just our big frontal cortex, or big frontal lobe, that excretes bigger synaptic activity that causes reason as an epiphenomenon? But this is the stuff that we have to, the hard, big questions we have to tackle. We're going to be, oh yeah, shoot.
To me, it's about the film.
Yeah.
Do you are in current to the pole now port? I mean, it's a moving.
Yeah. It's moving at something like 26 kilometers a year.
Oh yeah, it's 26 kilometers.
It was 100 years ago. It was only 4 kilometers.
Yeah, that's what it said. Speed up, eh?
It's speeding up, yeah.
It's speeding up.
And it moves with the bottom one too, but not as a dipole. It's a little discombobulated a bit.
I read somewhere that it said that if it's continuing this way, it's going maybe in 50.
Yeah, most likely. I mean, but the idea is always how do we organize ourselves? Since we can forecast what this change is going to be, the animals have to sort of move moment to moment. When they end up, acting on some weird anomaly in the field and find themselves drinking up all the oxygen in some little alcove, of Florida, and all being dead, it wasn't anything wrong. They just acted according to their nature. It was fine. They died, sucks. But with human beings, we don't necessarily have to just go over the cliff. We can get a concept of this future state before it happens and change accordingly. Yeah.
Just to go back to you brought this example with the birds following the magnetic field, and if you mess up with their beak, it tends to screw things up. But basically, if there's a shift in the magnetic field, as we talk, so you're basically saying that there's going to be probably millions of birds that will die in a matter of maybe a few weeks if they really go. If they're being brought into, let's say, in the cold and they die there.
Yeah.
So,
okay.
It's just that this idea of extinction, because then you could say, okay, well, we have let's say, one species or more of birds that disappears because of that. They're like wiped out because they all reacted to this change, but since they don't have anything to say about it, they just follow, then they disappear.
Yeah.
So this could have happened in the past as well, and this can happen in the future too.
Yeah, for sure. Yeah. Yeah, but it gets you out of this thinking small thing about evolution is just the battling of the genes, for survival, what pressure
Yeah,
is.
they weren't all killed by a bigger cat or something.
Yeah, right. Exactly. Yeah.
What relationship does the bob up and down of the solar system to the arms of the galaxy, what does that have as an effect on the magnetic field of the Earth?
I'd imagine quite a bit, but I mean, you're dealing with a 62 million year cycle. It's 33 million under, 33 million, or 30 million under, 30 million above, with a certain portion where you're actually inside of the arms of the galaxy, or the cloudy part of the galactic plane itself, which we're in right now. We're on a northward trajectory above it. Yeah, it undoubtedly has some huge effect. I think right now it's a different magnitude of cycle, though, that you're dealing with when you're dealing with the bobbing up and down than you are with the spiral, with the pole shifts. The pole shifts happen on a much more frequent basis. And I mean, I think these are some sort of discoveries we still have to make. But I know that one of the elements to consider also that you brought up the bobbing is that even though we're still in the galactic plane, we're on our way northward. The fact that we're in it creates a certain protective shielding. So the galactic, well, the sun has it's not just the cells, you and the Earth, that have geomagnetic fields, or that have magnetic fields, but the sun does too, our solar system, right? But the galactic plane also has a magnetic field that embraces all of the stars in our system, in our galaxy. We're talking about billions of stars, with God knows how many other systems out there. But when we move out of that protective shielding, the question is then, what type of extragalactic phenomena are awaiting us? How do we organize for that?
I had a comment.
Yeah.
These greenies, they're saying that man is destroying nature. I was just thinking about artificial, artificial ecological environment, or environment that we've constructed. How can we know that the species would not have gone extinct, like the species that went extinct and that we tried to save, let's say, and that eventually went extinct because it didn't work. Sometimes, there's not this question of the magnetic field or anything of that sort. So they would have, disappeared anyway, in the sense that we're not looking at really what's maintaining them alive. It's just a question of the environment, produce an environment where there's going to be enough sun or enough this, enough that, but we're not really discussing the magnetic field.
Mm-hmm.
So there's all these kind of new things that we're looking at.
You mean
they're not considered by the greenies in any cases. They don't. So I don't know the answer. It's like it's a question comment. I don't know, but I know for discussing with them that they don't really bother asking.
Can you give me an example? Do you mean in zoos they try to have preservation, habitats that reproduce a certain, when you go to the insectarium or something in Montreal, there's a certain yeah.
But they tried to, they said, hey, we're going to build something there, so we better move the population of whatever, of species of insect, and it just didn't quite work.
Well, I know from the discussion that Sky Shield brought up pertaining to the side effects of windmills and solar panels, is that, when you're dealing with the fact in solar panels, you have all these various species of mosquitoes, of these local, species that live in certain environments around deserts, which are attracted to the infrared radiations that are given off by these, you're covering an entire desert with solar panels. That's a lot of heat that's being concentrated onto these things. And that heat gives off a huge amount of infrared radiation all over the place. And these bugs, they see it, and in their sense perception, it strikes them as though that's the same quality of terrain that you would plant your seeds on, your eggs on, like certain water vibrations, we give off that certain infrared. So they plant all their eggs onto these solar panels, they get toasted, and they have whole species going extinct, because they're not taking into account the electromagnetic spectrum, where the birds the bats that are all getting like depopulated around the windmills, they're giving off sonar radiations all over the place, so it's scrambling all of their migrational patterns because they see through sonar.
Well, it's because of the wind pressure created, because of the windmill.
Yeah.
The pressure created in the air makes their lungs fill with blood, because their oxygen pressure changes. So they die as soon as they get in the vicinity of the windmill.
It's so vicious.
Yeah.
That's vicious.
Let alone the humans that have to die when you get these things up there too. We know that the question of energy is not very, very high on their minds if you're thinking about powering a modern society with these things. It's like kill off 90% of the world's population. I don't know if you guys knew that yet. Windmills and solar panels would necessitate that 90% or more of the world's population would have to disappear. You guys know? Have investigated that yet?
I didn't understand that.
Oh, I said that if you converted all of our energy sources around the world to simply wind and solar panels and like geothermal, then about 90% of the world's population would disappear. It would have to be, you'd witness a huge population reduction globally.
Because there would be less energy?
Yeah, the density of the energy sources,
Okay.
it's of such a low grade that doing those things required to power a modern society, no way. You couldn't even melt iron. You couldn't even...
They would have to turn the light off at Las Vegas.
Yeah, right.
Turn the whole city on.
You want to run closer, you're going to have to turn the whole city off. That's the energy flux density.
The what?
The energy flux density, that is the amount of energy in the shortest time. It's like if you want to cut vegetables, one of you with a sharp knife. If you have a huge meat to prepare, if you have a really blunt knife, it's going to take you a long time to cut the same amount of vegetable, right? So with using this energy flux density, this character of energy, at the most energy applied in the shortest amounts of time and space. So we find that the most efficient way of arranging energies is, all right, you have coal, you have wood, but more energy flux more better than coal is better than wood is coal, and better than coal is petroleum, and better than petroleum is uranium, better than uranium is thorium, based on this energy flux density.
Yeah, that's the before you get at money, when you're dealing with a real study of science of economics, the way LaRouche discovered it and applied it, the main variable, well, is one, scientific creative discoveries. But in terms of the material, if you're looking for material important variables to figure out how this population density can grow to the point of 7 billion over, you can sustain a huge number of people over a very small landmass, like in Montreal, 3 million. It's very small relative. It's by seeing that there's a correlation between the energy flux density and the flux density of population per square kilometer of territory on the Earth. This is something that every economics student should learn like day one. And then from there, that's the science of economics. So you have to make discoveries into fusion, into matter, antimatter. You have to always go to a higher grade. And that requires an understanding that, look, life is anti-entropic. This is where you get the idea of anti-entropy. Entropy is just simply the idea that all systems... Who's heard of entropy before? I'm sure you've heard. Entropy? No? Entropy? Ever heard of entropy? No? It's the idea that it's this cultish belief that all systems, fire, any type of system in your body, is always moving to lower states of potential, right? Whereas, and you'll get that, like in a fire, the fire is always consuming more energy than it's producing, so it's going to less state of potential. Now, in life, we discovered that that's totally the opposite case. Life, by looking at the evolutionary process, there's always more potential occurring, right? And also in the simple phenomenon of chlorophyll, you're dealing with something which is taking a very low wavelength source of energy, like infrared, it's a very long wavelength, And there's something inside of the chlorophyll molecule that increases that low wavelength, jacks it up to a higher wavelength of ultraviolet light. That ultraviolet is it's very small. I mean, you can't see with your eyes, but it's a very tiny comparison frequency. And that allows it to communicate to other cells to do the work that we don't have a clue. That allows it to, break down carbon dioxide, use it for yummy food, and create oxygen for us to breathe. So this is an anti-entropic character, not just to human populations, but you see it directly if you're a naturalist, just looking at the basics of nature. And ironically, the greenies don't do that. So they should give up their name.